So in our final part of section 5.6, this is part 3, we're just going to work some more examples to get practice at using those steps and to help you feel comfortable with how to write those answers. So example 7 says, find the real zeros of the polynomial function x to the third plus 3x squared minus 2x minus 6. And then it's asking us to use the zeros to factor f over the real numbers. Okay, so same process we've been doing. Let's walk through those steps again. The very first step is how many real zeros it has. So we know at most it will have 3 real zeros. Step 2 is our P over Q list. So plus or minus factors of 6 are 1, 2, 3, and 6. Factors of Q are 1. So I'm not even going to bother to list it because it doesn't change the actual list itself. Step 3 is to go ahead and graph it. So from the graph, and now the graph, when you graph this using either Desmos or your graphing calculator, you're going to see that it kind of looks like this. And this is, again, just a really rough graph. It does this, it does this, it does this. So something like that, right? So this one is clearly -3. So what I'm going to do is take that picture, compare it to my list, and I can see that that's -3. However, this guy and this guy are not on the list, not on list, because our list doesn't include any fractions, right? So, and those guys are not integer values. So we'll deal with those in just a minute, but that's why having the list is so important, so we can compare things and figure out where we're pulling stuff in. Okay, so from the graph, we're going to use -3. And we're going to use -3 in our synthetic division. So we have a 1, we have a 3, we have -2, and -6. So we'll bring down our 1. -3 times 1 is a -3. That gives me a 0. Don't freak out. It's okay. 0 times anything is 0. Adding that column is -2. -2 times -3 gives me a +6, and adding that column is 0. So again, here's my proof that I found a 0. And we have a depressed equation down here. So this is a 1x squared. We have no x and a -2. So now what we're doing is we now need to solve x squared minus 2 is equal to 0. We can do that. It's a quadratic equation. The quickest way is to move the 2 and then square root both sides. So x squared is going to be equal to 2, and x is equal to plus or minus the square root of 2. So to answer the question, the real zeros are the -3, a positive root 2, and a negative root 2. Now this guy is a rational number. These two are irrational numbers. They involve radicals. Now, that's not the technical definition of an irrational number. It is not. But for our class, the only irrational numbers we really see are pi and radicals. So, okay. So the reason that these two did not appear in this list is because this is only the list of possible rational numbers, not the radical numbers. These other two zeros are the square root of 2, whatever that is, 1.3, 1.4, something like that. So, and there it is. It does ask us to write it in factored form. So to finish off the problem, we know that f of x factors into an x plus 3, that's from this guy, an x minus the square root of 2, and an x plus the square root of 2. Now, you would never have been able to factor that before, but now you can. It's kind of cool. Okay, let's try another one. Excuse me. Example 8. So example 8, same directions. We're now going to throw a coefficient in to show what's going on. Find the real zeros of f of x is equal to 5x to the third plus x squared plus 10x plus 2. So we're going to find the zeros, and then we're going to factor it over the real numbers. So same steps. Because it's a cubic, we know that we'll have 3 zeros. We could have 3 zeros. We need our P over Q list. This time it gets a little uglier. So factors of 2 are 1 and 2. Factors of 5 are 1 and 5. So I end up with some fractions here. I'll have 1 over 1, 1 over 5, 2 over 1, 2 over 5. So sure enough, I get some fractions. Okay, step 3 is the graph. So go graph it. What you're going to notice this time when it graphs is that it only crosses the x-axis one time. So the picture, I don't know how the picture with me, it does, does something like this, right? So it only crosses the axis one time. That tells me it only has one real zero and only one. So our list of 3 up here is going to be somewhat misleading. It's not wrong, but we only have one real zero. So we're going to compare that picture to this list. It's definitely less than -1, and it's closer to 0 than it is to -1. So we're going to call it that -1/5. So again, look at that picture carefully. So in our synthetic division, we're going to use x equals a -1/5. That's why we have the list. So we'll use -1/5 in the box, and our coefficients are 5, 1, 10, and 2. We're going to pull down the 5. -1/5 times 5 is a -1. Adding gives me 0. Multiplying is 0. Adding is 10. And -1/5 of 10 is -2. Adding gives me 0. So again, there's our proof that we've got a 0. What's left down here? Well, what's left down there is 5 with an x squared, no x, but a 10. So 5x squared plus 10. Well, I'm going to set that to 0. I'm going to solve that. That'd be 5x squared equals a -10. X squared equals a -2. And then when we square root it, we get plus or minus the square root of a -2, which is plus or minus I square root of 2. These are non-real. They are zeros, but they're non-real zeros. And your book separates these into the next section, 5.7. So as far as this section is concerned, we're only looking for the real 0, and the only real 0 of this polynomial is this -1/5. So when I write this in factored form, let's make sure we're answering the question. So the real 0 was a -1/5. And in factored form, f of x has factored into x plus 1/5. And then what was left over is the depressed equation of 5x squared plus 10. And because those are non-real zeros coming out of that quadratic, we won't list them. So there it is. I would like to point out that another way of writing this x plus 1/5 would be 5x plus 1 times 5x squared plus 10. We'll tend to write it this way, right? But notice if we solve this and solve this, we get the same answer out of both of them. The misleading part about this is if I write it like this and I have it factored this guy, then I don't end up, when I FOIL it back out, this 5, I'd end up with a 25. So, but as a comment, sometimes you'll see textbooks that do that. So, okay, one more. We've done a lot of cubics. Let's go do a 4th degree to show you why that depressed equation is so crucial to our work. So this is our final example. So example 9, we're going to come in and do the same process with 2x plus x cubed minus 7x squared minus 3x plus. So this time we know that there could be 4 real zeros at most. Our P over Q list is a little bit obnoxious again. So all factors of P, which are 1 and 3, over all factors of Q, which are 1 and 2. So that's going to give me 1, 1/2, 3, 3/2. Great, wonderful. Then we'll go to the graph. So from the graph, and it looks like it's crossing it through 4 times. So the graph looks something, and again, my picture is not any good. You need to be looking at your picture. So I don't know, it's something like that. That's not right, but it's crossing it 4 times. So we have 4 real zeros. We need to go find all 4 of them is what we're after. So we're going to compare that picture to our list. And when you compare that picture to your list, we can see that -1 is a 0. So from the graph, we're going to try x equals -1. That's the easiest one to pick up, so we'll pick it up. So we have as our coefficients 2, 1, -7, -3, and 3. So I'll bring down the 2. 2 times -1 is -2. Adding is a -1. Multiplying is a +1. Adding is -6. Multiplying is a +6. Adding is 3. Multiplying is a -3. And sure enough, there is our zero. The difficulty is this was a 4th degree. So our depressed equation down here is a 2x to the 3rd. So this term right here would be a 2x cubed minus 1x squared minus 6x plus 3. Okay, that doesn't work for me. I need to get it down to a quadratic so I can use my traditional factoring methods. So we need to find another real zero from that picture. And from that picture, comparing that picture to the list, we're going to see that a positive 1/2 is also a zero. So x equals 1/2 is another zero. So those are the places where we're crossing the axis are not any place in our list. So we're going to use 1/2, but I'm not going to go back to the beginning, because if I go back to the beginning and use it again, I'll still end up with a cubic. I'm going to start from this point in time. So I'm going to use a 1/2 on the depressed equation. So never, ever, ever go back to the original. Always work off the depressed equation. So we'll bring down the 2, multiplying by 1/2 is 1, adding is 0, multiplying is 0, adding is -6, multiplying is 3, -3. Make sure I watch my sign. Adding gives me 0. So be very careful. Don't go too fast. Beautiful. So this was an x cubed. Started off with an x to the 4th. We have an x cubed sitting here. This is an x squared. So what's left down here is 2x squared. -6 is equal to 0. Again, these zeros are nice and they pop up a lot in this section because they have to be careful about what they give you as problems. There's no x term, so we end up with a -6. So that'll give me 2x squared equals 6. X squared is equal to 3. So x is equal to plus or minus the square root of 3. So we end up with 4 real zeros. The real zeros of this polynomial function are a -1, the positive 1/2. Both of those are rational zeros. And then we have a -√3 and a positive √3, and those guys are irrational zeros. So they show up on the picture, they just don't show up in the list. And then in factored form, which is kind of impressive, we're going to end up with x plus 1. We'll have x minus 1/2. We'll have x plus √3. And we'll have x minus √3. Okay, now, this is where we run into a little bit of difficulty. If you ask me, if you were to pull all this back out, you get an x times an x times an x times an x. That's not going to give you this 2 at all. It won't. So in this case, because we've broken it all the way down to linear factors, x, we're going to rewrite this 1/2 so that if we were to multiply it out, we would get the right answer. So this would be 2x minus 1 times x plus the square root of 3 times x minus the square root of 3. And there it is in factored form. So I'm simply translating this x minus 1/2, right? X minus 1/2 equal to 0. If I multiply everything by 2, I would get 2x minus 1. So I'm taking the fraction back out of it. Now, if you multiply this back out, you'll get an x times a 2x times an x times an x, which is going to give you that 2x to the 4. And those are the real zeros of polynomial functions.